Okay, so this is a talk about the Open Policy Agent project. My name is Torin. I'm one of the co-founders of the project and one of the core contributors. I've also worked on policy-related features in Kubernetes and Istio lately. And I happen to love good restaurants, so this is a perfect city to come to talk about policy. So for this talk, what I thought I would do is just jump in right away to some new technology that we've been working on. And I'm really excited about this. This is the wiki. I think that this represents the future of policy enforcement. As you can see, it's got this great high-level language that you can use to write policy on. Pretty much anybody can read and write this. It's super easy to update. It's got built-in contribution guidelines and conflict resolution, and I think that policy enforcement's basically solved, right? So I haven't lost my mind. I'm not serious. I think that this is a bad idea. Don't do it. But at the same time, I think that for a lot of us in our day-to-day lives, when we're working with policy, this is like the best that we can do because we've got so many things to worry about. And so we often fall back on things like wikis and spreadsheets to keep track of the system and to manage the policies in the system. Now, what I want to talk about today is this idea of decoupling policy decisions from policy enforcement, because I think that this is actually a really good idea. So if you take anything away from this talk, the idea that you should take away is that you should treat policy as a separate concern. So just like you think of the database and your message brokers and your monitoring and your logging and all of those components as boxes in your architecture, you should also think of policy as a box in your architecture. And if you do that, what you're going to get, if you decouple policy decisions from policy enforcement, and you think of policy as a separate concern, you're going to get better control and visibility over permissions and policy and security throughout your system. Now, when I think of policy, I think of like a set of rules that are supposed to govern how the system behaves. And while that's a sufficiently general definition, it's not great because it's not very concrete, and so it's not very satisfying. But regardless of whether you have a clear idea of what policy is in your mind or you have a definition of it in your organization, I would argue that many of you probably work with policy on a day-to-day basis because it actually affects all of us all the time. So whether you're working at the application layer or with Kubernetes or with host-level infrastructure or cloud infrastructure, whether you care about things like how end-user data gets handled or where workloads are deployed or who can SSH into a machine or whether a config change is going to have a negative impact on your infrastructure, you all have to deal with policy all the time in your day-to-day lives. And so policy enforcement is actually this fundamental problem that we need to have good solutions for. Because if we don't have a good solution for policy enforcement in the organization, then we're going to risk massive fines, security breaches, outages, downtime, you name it. So it's something that we have to solve. But at the same time, like I said before, we often fall back to things like wikis and spreadsheets. So there's this term called tribal knowledge, which basically means like know-how or the collective wisdom of the organization. And so a lot of the time we rely just on tribal knowledge to run these systems. The problem with tribal knowledge is that it doesn't provide any guarantee that policies are being enforced. You're basically just hoping that workloads get deployed to the right place and that firewall rules get provisioned correctly and so on. Now, a lot of us are software engineers and we look at these kind of problems and we think, okay, well, we can build a solution to go provision firewall rules or to authorize requests. But the problem is that a lot of the time when we do that, we end up hard coding the policy decisions that are really important that operators need to be able to control into the software that we build. And so we end up with these really tightly coupled, hard-coded policy decisions in the services and the applications that are actually really expensive and painful to maintain because they're so tightly coupled with the business logic. And so if you want to change the policy or test the policy or understand the policy, you need to be intimately familiar with the application. And so operators and administrators are not able to easily change the policy and enforce new policies as they evolve over time. So these are some of the problems that we set out to solve when we created the Open Policy Agent project. So OPA, or OPA, if you can call it whatever you want, is an open source general purpose policy engine. And what that means is that you can take it and you can use it at any layer of the stack in any system. Now, when you're using OPA, what you're doing is you're offloading policy decisions from your service. So you're decoupling the policy decision from the enforcement piece. And that's why you can basically take your service and you can you can use it to, you can offload policy decisions from your service. And so, for example, if you're building like a microservice with an HTTP API, you need to authorize the requests that are coming into that API. So for example, if your service is serving an HTTP API, then whenever it receives a request, it would query OPA. And when it does that query, it would supply a bunch of input data, like the method and the path and so on, that inform the policy. And then OPA would evaluate that input against all of the policies that it has loaded, as well as data and context that you could add as well. And so the output of that decision might be like an allow or a deny or something like that, and that gets sent back to your service so that it can be enforced. So the important thing here is that we're decoupling policy decisions from policy enforcement. Now, when we think about OPA, when we think about how it fits into the architecture, we like to think of it as a host local cache for policy decisions. So what this means is we're basically taking OPA and we're trying to join its life cycle with the life cycle of your service. So we run OPA on the same machine as your service, whether you're using it as a library or a host level daemon or a sidecar, it doesn't really matter. It's the same model. You're offloading decisions from your service to OPA. Now, the reason why we want to do this, why we want to join the life cycles and why we want to deploy them together is because of two things. So first of all, we want to reduce the amount of latency that we introduce into the request path in order to use OPA. If OPA is running across the network on another machine, then every single time your service has to make a policy decision, like every time it has to authorize a request, it's got to go across the network. It's got to pay a network hop in order to get that decision. And so that obviously is going to impact latency and performance, and that's not really acceptable for the project. The second reason, and actually it's a more important reason, is around availability. So OPA has been designed to leverage this notion of fate sharing, which basically means to couple the life cycles of the components. And by deploying OPA on the same machine as your service, you're guaranteed that as long as your service is up, OPA is up, and it can get decisions. It's not on another machine that could fail, or it's not on another machine separated by the network where the network could go down. It's on the same machine as your service, and so it can always get decisions. So you want to leverage this architectural pattern known as fate sharing. Now, in order to make all of this work, we've made certain design decisions with OPA. And so we designed it to be as lightweight as possible. And so to do that, there are a couple things. So first of all, policies and data are all stored in memory. So when you ask OPA for a policy decision, it's not calling out to an external database to get the policies or get the data that it needs. Moreover, when you ask for a policy decision, it doesn't call it to any other service. So all the decisions are handled locally on the machine with policy and data cached in memory. Now, you can extend OPA to call out to other services. You can do that in the policy. You can have something that does like an HTTP request to get data if it needs to. Or you can take OPA and you can extend it to call out to like MySQL or something like that, where the policies might be stored or where additional context is stored. But on its own, OPA is not going to do that. It serves decisions on the host that it's deployed on. OK, so let's take a look at how this works. So I've got my favorite friend here, Bob. He's a cloud engineer. And this is an employee profile page. So we've got some employee details and performance reviews for Bob. Now, this application is actually implemented by a handful of microservices under the hood. So there's like a landing page that stitches everything together. There's a details service that provides employee details. There's a performance review service that serves up the performance reviews, and so on. And so using this application, we can actually demo a few different policies. But the way this is going to work is that when my browser asks the landing page for the employee profile, the landing page is going to go to reviews and say, give me the performance reviews, and then it's going to go to details and say, give me the employee details, and then it's going to join those things together and serve them to the browser. Now, each one of these services is going to call out to an instance of OPA and ask for a policy decision at each one of these hops to say, should this request be allowed? Now, in order to make that decision, OPA needs to have certain data that it can reason about. And so in this case, the services provide things like the method and the path and the user and so on. And so the policy is going to be written to evaluate against these things and produce decisions like allow or deny. So the first policy we're going to show how you can implement is one that says that basically employees can see their own reviews as well as the reviews of their subordinates or the people they manage. The second policy that we're going to show is one that says that employees can see their own PII as well as HR. So HR is special, they can see PII. Now, PII just means personally identifiable information. It's just like a standard term for things like a social security number or a national health insurance number or something like that. OK, so let me switch to my terminal here, and I've got this running. So these services are running right now on top of Docker Compose on my machine, and they're all asking a local instance of OPA for policy decisions. And right now, this is the policy that OPA has loaded. And OPA is actually watching this policy for changes. So whenever I change the file, the policy is going to update in OPA, and you're going to see the changes reflected in the application. So right now, I'm not signed in. You can see I'm not signed in here. But all of the details are being displayed, and all the reviews are being displayed. And so what's happening is that the services are querying this allow rule, and they're asking, what's the value of allow? And by default, it's going to come back as false. But if one of these other rules in this file allow, or decide to allow, then the request will be allowed. So right now, we're interested in performance reviews. And we can see that it's going to allow if the input method is get and the input path, it matches this pattern. But what we want to do is restrict it so that only employees can see their performance reviews, first of all. So what I'm going to do is get rid of that line and uncomment those two, and then save. And now if I refresh the page, you can see the performance reviews aren't displayed anymore. The reason for that is because the policy is deciding what the application should be able to present. Now, I'm not logged in, and so that's what we want. But if I log in as, say, Bob, he's able to see his own performance reviews. But if I log in as like his coworker, say like Alice, or rather, Alice is the manager. Sorry, Charlie is the coworker. He's not able to see the reviews either. But suppose I log in as Alice, who happens to be Bob's manager. Right now, she can't see the performance reviews. And so that doesn't really satisfy the policy that we want. So in order to handle the second part of the policy, we're going to take this other rule here, and we're going to uncomment it. And now when I refresh the page, the performance reviews show up. Now, what I've done here is I've actually hard-coded the management chain of the organization into the policy. And so I'm saying that Bob reports to Alice and Charlie reports to Alice. Now, this data is hard-coded in the policy so that it's simple to demonstrate. But you could also just load this in as raw data, like raw JSON, raw structured data, through an API. And so you could pull data out of LDAP or AD or whatever system you use to keep track of this kind of information, and you could load it into OPA and use that to inform your policy decisions. You could also get this information into OPA through something like a JOT token, and so that way you don't need to take a dependency on AD or something like that. Okay, so this demonstrates a simple idea of like controlling access to certain APIs. Now, the other thing we want to do is we want to restrict access to sensitive data. In this case, I'm logged in as Alice, who's a manager, but she can see the social security number here. And that's not good. Social security number is like very sensitive. Only HR should be able to see that. And so I actually have another rule down below here called PII. And this PII rule is going to define what fields are actually containing PII. And so if I go back to this slide, you can see that the details service is integrated with OPA. And so every time details receives a request, it not only asks, should this be allowed, but it asks, what are the fields that contain PII? So it's querying for this PII decision. And so if I refresh the page now, we can see we're logged in as Alice, the manager, but the social security number is blanked out. Now I've happened to like also hard code who's in HR here. We've got Ken and Anthony. So if I log in as, say, Ken, that should not be displayed. So I go Ken, great. So now Ken can see the performance reviews and the social security number. And so I can actually change this if I want. So say Bob is actually getting like nervous about his old age and he doesn't want people to know his birth date. We can make that private as well. If I go and I sign out, now the birth date and the social security number are not being displayed. So this gives you an idea of how you can actually produce policy decisions that are not just Boolean, allow, deny, or true false values. You can actually generate arbitrary JSON data in your policies with OPA. Okay. So what I want to do now is take a look at OPA's policy language, because that's the core thing that it provides to you as a user of the project. So the language is this declarative, high-level declarative language, and we call it Rego. And it's designed so that you can like answer questions like, should this user be allowed to do this operation on this resource? Or what annotations need to be added to new Kubernetes deployments when they're created? Or which users can SSH into production machines, and so on. The language itself is actually really focused on two things, logic and data. It's not, so when you're writing policies, you're not really thinking about like system calls or class hierarchies or which function you need to invoke on an object or anything like that. You're just focusing on purely on the logic and the data that's relevant to policy. Because policy is all about just making logic or making decisions which are based on logic and data, and so that's what you want from the language. So let's walk through this example. So the example in English says that employees may read their own reviews and the reviews of their subordinates, the people they manage. Now in English, this statement has sort of two parts to it, and so we're going to actually create two separate rules to deal with this policy. Now in order to actually evaluate the policy, we're going to need some input data, and so I'm going to say that the method is set to get, and the path is set to reviews Bob as an array, and the user is set to Bob. Now, I've represented the path as an array here because OPA's language allows you to do pattern matching on data, and you'll see that in a second. So the first thing we're going to do is create this rule called allow that you saw a minute ago. And you can basically understand this as allow is true if input method matches get, and input path matches reviews employee ID, and input user matches employee ID. Now, the meat of this policy is actually the last line there, input user matches employee ID. Because employee ID is actually a variable, and that variable is going to get bound to a value when OPA evaluates the rule against the input. And so in this case, employee ID gets bound to Bob. And if you just sort of walk through this in your head, you'll see that on the left-hand side, it's going to be get, and then reviews Bob, and then Bob. And so all those things are equal, and the rule is going to succeed. So the statements in the body of the rule are basically ANDed together. Now, let's try this with a different user. So say we have Alice requesting Bob's performance reviews. In this case, employee ID is going to get replaced with Bob, but input user happens to be Alice. And so when OPA gets to that last line, it's going to fail, and it's not going to be able to find a way to prove that this request should be allowed. But suppose that Alice is actually Bob's manager, and she should be allowed to see these reviews. And so that fact that Alice is Bob's manager can just be represented as data, as structured data that you put in the policy, or that you load in through an API, or that you include in the input. And so on the bottom right here, you can see I've defined a simple mapping that says that Bob is managed by Alice, and Alice is managed by Janet. Now, in order to make use of this data, or this context, as we like to call it, you have to add another rule. And so this rule is going to be very similar to the first one. We're going to match on method and path. But then instead of checking whether the user is equal to employee ID, we're going to check if the user is equal to the result of looking up the employee ID in that data structure. And so then the same thing's going to happen when we evaluate. It's going to substitute Bob for employee ID. And then it's going to do a lookup to substitute Alice for that reference. And so then obviously when OPA goes through this, it's going to find that all these things are OK, and so the request would be allowed. So the statements in the bodies of the rules are ANDed together, and the statements in the head of the rule, these allow statements, are ORed together. So that's how you can understand these policies. Now, so far I've basically been talking about like microservice API authorization or service authorization. And one of the things that comes up when you talk about API authorization a lot is role-based access control, or RBAC. And the question that people ask is, well, isn't RBAC enough? Like, why do I need anything else other than RBAC? And the answer is that in a lot of cases, you don't actually need anything else. RBAC is probably, it could be sufficient. It actually depends a lot on your use cases, like how complex your use cases are, and actually how much you trust your users. So RBAC's good when you have simple use cases and you trust your users. But as soon as you cross that threshold, RBAC is not enough, and then you're stuck and you need something else. So RBAC only knows about the resource, the name of the resource, the action, and the subject. If you're creating a Kubernetes deployment or a Kubernetes pod, you might need to reason about all kinds of things that define that pod, and RBAC's just not going to be able to do that. So if you need to write fine-grained policies that restrict or constrain the system, or you need to leverage external context in your policy decisions, you're going to need to go beyond RBAC. But at the same time, RBAC is nice in a sense because it's so simple, and the API it gives you is fairly easy to understand. And so let's just implement RBAC with OPA. So in order to do that, we need to define a simple RBAC model. And so I've got here roles and bindings. So bindings associate a user with a role by name, and then roles grant permission on an operation. So this is just like the RBAC model you have in Kubernetes. It's a little bit simpler, but you could basically load this RBAC configuration into OPA as data, just like the data that we had for the management chain. Now, in order to make use of this data, again, you have to write a rule. And so this rule is going to look like this. So we're going to say allow is true if there's a binding that matches the user, and there's a role that matches the resource and the operation in the input, and there's a role that, and that the role matches the binding. And this is actually it. So actually, if you just took this rule as is and some data that looked like this, it would work. You would have a basic RBAC system working. Now, the interesting thing about this rule that is different from what I showed you before is that there's actually a search happening. So this rule is searching over the RBAC data that we've loaded into OPA. So those first two expressions in the body are basically finding bindings that match the incoming user. And then the second set of expressions is finding a role that matches the incoming resource and operation. Now, the interesting thing about this is that it's doing a search. And with a search, if the number of roles grows or the number of bindings grows, the search is going to start taking longer and longer. if OPA wasn't smart, if it just evaluated these things naively. But even without changing this policy or changing the structure of the data in any way, there are a couple things that OPA can do to make these policies perform well. So the first thing that OPA is going to do is it's going to partially evaluate your policies. So partial evaluation basically takes rules and data, and it combines them, and it outputs new simplified rules. So all the search and all the complex expressions in the original policy get evaluated out, and then the thing you're left with are these nice, simple policies that only contain references to unknown values like the input, the incoming request, and constants. Now, the nice thing about these simplified rules is that OPA can actually reason about them because they're simple enough. And so OPA does reason about them, and what it does is it builds an index out of these rule sets. So it actually builds a tri-data structure by looking at the expressions in the rules and building an index out of them. And so in this case, things like the incoming user and the incoming resource and the incoming operation all contribute to this trie structure. So they become nodes in the trie, and then the constants become edges in the trie. So OPA builds an index out of these rules, and then what it does with that index is it uses them to look up the rules that apply to the input whenever you execute a request. So when your service queries for the value of allow, it's going to supply the input like the user and the resource and the operation. And then OPA is going to use that to quickly find all the rules that could possibly apply. And then what happens is that OPA just evaluates those. And when it does that, it can skip all the other rules that don't apply to the input. So it can ignore those. So there could be hundreds or thousands of those rules, and OPA doesn't have to care. It just skips right to the one that matters, it evaluates that, and it's done. And so when we use partial evaluation and we use rule indexing, we see latencies of around 50 microseconds when you're talking about like 250 roles and 250 bindings. But the really cool thing about it is that even as you scale the number of roles and the number of role bindings, the latency is like 60 microseconds at an order of magnitude larger. So OPA is scaling really well as your data set grows. So I went through that a little bit quickly. There's a blog post on there are blog posts on both of these things, so if you're interested, I recommend you check those out. Now, at the beginning of the talk, I was mentioning about how there are all these different policies, and so whether you care about end user data or Kubernetes or Terraform or whatever, you're all dealing with policy. And I think that it's really easy as software engineers to look at these problems in isolation and decide that, well, this needs to be solved independently. But I also think that it's possible to look at these problems and see a lot of commonality. And when I see commonality as a software engineer, I like to build a general purpose solution that solves it, because then I don't have to go and reinvent all the performance optimizations and all the tooling and get it right and all the pain of that. And so you can actually use OPA today to enforce all kinds of policies across the stack. So OPA is integrated with Kubernetes for things like admission control and federated placement. You can actually even use it as an authorizer there. It's integrated with frameworks like Spring and service mesh projects like Istio and Linkerd to do API authorization on your microservices. You can do risk management over Terraform changes in your CI/CD pipelines. You do access control at the host level over who can run sudo commands or execute SSH into the box. And we've recently integrated with Kafka, so you can enforce access controls over who has access to Kafka, maybe based on context or other fine-grained permissions. Now, the reason why this is possible is because we're treating all of these projects just as data. They're all just data. They're all just JSON or structured data that we load into OPA, either as input or as context. So regardless of the idiosyncratic way that these projects happen to represent their APIs or their data, it doesn't matter because OPA doesn't care. It's not coupled to any of those data models in any way. And so that's why we call OPA general purpose, because you can just apply it at any layer of the stack and just load data into it and write policy against it. Now, obviously the policy has to apply meaning to that data, but OPA doesn't care that that's in the policy. OPA is not coupled to any of these things. And so this is some of the value that companies like Netflix see when they're using OPA. So Netflix was one of the early adopters of OPA. And for them, they have like a very complex environment with thousands of services and a number of different resource types that they want to enforce authorization over, and different identity types like VMs and containers and batch jobs and full-time employees versus contractors and so on. And they have all these different protocols and languages that they use to implement their service. And then on top of all of that, they have strict requirements around latency. They need to be able to tune the policies according to the application and the resource types. And they want to be able to test the policies to know that they're correct. if you just hard-coded all of this stuff into the service, you wouldn't be able to change it easily, and you wouldn't be able to test it. And so OPA lines up really well around flexibility and ability to capture intent. It also helps that it performs really well because it doesn't introduce a significant amount of latency into their request path. And so today they have OPA integrated with HTTP and gRPC APIs, Kafka producers, and other things are coming. So we're super excited about that. If you're interested more in how OPA or how Netflix is using OPA, check out the talk that we did with them at the last KubeCon. So this is sort of where we're at today. We have like 20 plus companies using OPA actively across a bunch of different fields or industries like finance, service providers, IT companies, software vendors. And they're using OPA across the stack to enforce authorization policies in microservices and orchestrators, admission control, and so on. They're controlling things at the host layer. They're trying to protect their data. And it's really neat to see them gain a lot of value out of having this general purpose solution. And so what we love with OPA are new use cases, because we've already applied it to RBAC and ABAC and admission control and data protection and so on. So if you have a new use case, we'd love to hear about it. Please bring it to us, and we'd be happy to help you get started. So it's really cool to see all this coming together, to see this general purpose solution solving these problems, because what that means is that you don't have to re-implement the same optimizations, you don't have to re-implement all the tooling. And so what I thought I would do is demo something new that we built just recently, which is an integration with VS Code. So I don't know how many people here use VS Code, but it's a great IDE. I actually have the same policy that I was talking about before here in my VS Code. And there's a few things that I want to show. So the first is that you can actually just evaluate the policies in the IDE. So for example, if I want to know what the value of allow is, I can do that. And right now it's telling me that it's true. If I want to know what the value of all the rules in the package are, I can do that. So it tells me allow is true. I've got a bunch of test data here that's showing up. It's telling me that PII's got SSN in it. And so it's basically going through all of these rules and evaluating them and telling me what the values are. Now, in addition to just evaluating everything in the package and the rules themselves, I can also actually just evaluate expressions in the bodies of the rules. And so this is really useful when you're debugging, because you want to know what the value of things are. So for example, here I can select this line and evaluate it, and it tells me that that's true. And it's true because I've actually got this file called input.json here that's got a sample request in it. So the method here is get, and I've selected this line here, method equals get. Now if I do these next two lines, what's going to happen? Well, it's going to tell me that employee ID is Bob, because it can tell that the first line is satisfied, but there's a variable in the second line, and so that gets pulled out of the path and bound to the variable there. So that's the same variable binding that happened when I walked through the policy on the slides. And so then I can go to the last expression again, and it's the same output. So this is really useful when you're writing the policies, when you're debugging them, because you want to know what's going on. You want to sort of inspect the data and kind of figure out what's in there and how you can use it in your policy. Now, once you've done that a little bit, you want to kind of move ahead and move to a more kind of like production setting. And so you want to actually test that your policies are correct. You don't just want to be like evaluating them manually every time you've made a change. And so we've actually got a test framework that you can use to write tests for your policies. And so this is what that looks like. And so here I've got tests for my different policies here. So I'm testing that reviews is allowing input for when Bob asks for himself, or when a manager asks for Bob's performance reviews, and so on. And I can go and I can just evaluate the entire workspace here, and it'll tell me that all the tests are passing. Now, if I made a mistake and I said that, well, okay, coworkers should be able to see performance reviews, and I rerun this, test package, test workspace, we see that one test is failing now. There it is right there. So you can basically build up these suites of unit tests for your policies and gain confidence that they're correct. But sometimes the set of policies is large, and you want some sort of like higher level tooling for that. And so one of the things we started doing is building in test coverage. So I can run coverage on the workspace. Oops, it's failing, so it's not going to generate the coverage. Let me fix that. Toggle coverage. So now it's telling me all the lines that are covered in the policy. And so the test is just another policy, basically. So it's telling me that the test is totally covered. And if I go look at my policy now, we can see that all these lines are hit. But if I go back to the test, say I just get rid of all of these. Oops. Let me just get rid of this. And I'm just going to say test true. I'll just get rid of that test entirely. And now I do the coverage again. OK, well, now the test input's not being used. But more importantly, in my policy, I'm never hitting these rules. So I'm never hitting these endpoints here. OK, so that's just a quick sort of demo of the VS Code integration. Right now, it's on GitHub, and we're hoping to get into the marketplace soon. We just haven't had time yet. OK. So hopefully I've convinced everyone in the room that policy decisions should be decoupled from policy enforcement. Because when you do that, you enable a general purpose solution that can be optimized and support great tooling. If you're interested in the project, I recommend you check out the website. We have tutorials for things like HTTP API authorization, admission control, risk management, data protection, and so on. So go look at the website and try these things out. And I hope that you'll find that you can actually leverage OPA to solve fundamental security and policy problems in your organizations, because that's why we built it. So thank you very much. This is the repo. Please start on GitHub. It kind of matters for open source projects these days, I guess. But yeah, that's it. Thank you. Questions? In the front?
Is there some kind of integration for Vim?
So the question is there an integration for Vim? No, there is an integration for Vim, but it doesn't have all the evaluation in it. So it'll do syntax highlighting and reformat your policies for you. But yeah, but it could be extended. So in the middle there.
I got a feeling that the OPA could really use some sort of control plane, some centralized area for managing your policies and maybe even collecting all the data around your system. Are there any plans of someone doing something like that?
So there's a startup that's doing that right now. OPA, in the last release, we added a number of features that enable that. So we have a thing that'll tell OPA to download policies from a remote endpoint. Through a simple API, we have a thing that'll tell OPA to upload status updates to a remote endpoint so you know if your policies are synced correctly. And we have something that'll also record decisions that OPA is making in memory, and then periodically update batches of those to a remote endpoint as well. So those APIs are on the website. You can check them out, and they're pretty simple to implement. So I think that hopefully we see like these policy control plans popping up. One more?
Yeah, I have one more.
In the middle there, yeah.
Distributed system aspect of it. Are there any recommendations right now where it's kind of hacky?
Yeah, so if you're, I don't know how you're doing it right now, but so so OPA exposes APIs that allow you to load the data in. So you could build that distribution piece that basically makes very specific fine-grained updates to the data that's in OPA. So if you're loading in large batches of JSON, then you'd probably want to use some of those APIs. You could also check out the bundle API that I mentioned a minute ago that'll download things for you. So it depends what I can chat with you afterwards about the specifics of that. Yeah, let's chat afterwards about that. In the back there.
You're managing all the examples. Does it support hierarchy? Is it easy to support hierarchy?
So the question is, can you support hierarchy in the policies?
Yeah, because your manager of it is just one level.
Right, yeah, so actually that example came from Netflix, and for them they do have a hierarchy, and they just basically represent that in the data, and then the data can search over the hierarchy. So yes, you can support hierarchies to some extent. It depends on like what you're trying to do. If you're trying to do like a graph traversal, then it's not a great fit for that, but certain types of hierarchies are easily supported. More questions? Okay, yeah, sorry, again.
Some more specific question on the SSH integration that is out there today.
Uh-huh.
Is it literally just you're allowed to come in and not allowed to come in, or does it actually handle the part where, let's say, if you have like 1,000 nodes out there, it needs to create sort of a home folder for that user that's trying to log in, or does OPA integration today does not handle that part?
I'm just trying to remember now. Okay, yeah, so the integration today is for authorization. It does allow you to present prompts to the user, so you can generate prompts in policy and then have those sent to the user. So like one of the use cases was that a company wanted to restrict who could SSH in based on whether there was like a ticket open for that user for the application that's running on that box, and so the user would enter the ticket. But that, no, it won't create the user. You can tell it to run commands, but I'd have to go back and look. I can't remember. I didn't write that integration, so I don't remember the details of it. Any other questions? If not, I can wrap up. No? Okay. Thank you very much.